Hi everyone, so this is Xiaofu. I have both a background from electrical engineering and also mechanical engineering. So from our last tutorial, Series 2, we have some basic informations from FPAA simulator. And we'll learn how we can add up two different constants and also one constant with another sinusoid. So in the newer or in the current tutorial, Series 3, we will go and get more familiar with more basics. And here we have three different goals for this tutorial. So the first one, we are going to understand why or how we actually can match up different phases between different modules. And also other than that, there is also a module called sample and also hold. So I will give more details in the later of the tutorial. So it actually helps us to visualize the results more continuously. Another, I would say, goal is that we can also try to change the clock frequency. So some of you would like to work with low frequency components or sinusoids, but some of you might prefer to work with high frequency. And the last one is how we can check the capacity of the FPAA. So each one of the FPAA has their own limitations. It only have that much amount of components, so you wouldn't be able to do all the operations in a single FPA. Then if you would like to have more complex or more advanced manipulations or functionalities, then you might need to have another FPA. So okay, let's get back to the simulator. So this is our simulator. I have a few from my previous tutorial. I teach you some of the basics where we can zoom in and zoom out. So if you confused about some of my I would say some of my here what I showed. If you feel confused, you can just go back to my previous tutorial, and then we'll just zoom in, and make it larger. So we'll be that so that'll be easier for us to work with FPA. And right now, okay, I might just get quickly to what we have learned last time. So I will insert a new cam. So from here, let's say last time we used a summation, so between two different components. So this time we'll use the same module. And here it also asks us, let's say, okay, you need to set up the sign and also the scaling factor. So we'll keep as it is. And then last time we used one constant voltage and one sinusoid. So this time we'll use two different sinusoids so that we can have more fun, I would say more results that is different from the previous tutorial. And I will insert another cam. This is called a sinusoid or oscillator generator. You see here, from here it says sine wave oscillator. Double click and put it here. And you can set up the amplitude and the frequency. Let's say we'll use maybe a bit lower frequency, 50 kilohertz. And here you see from the very, I would say, last of this explanation, it's tell you what was the limitation. And the frequency you can set up right now is between 40 kilohertz to 800 kilohertz. While whenever you change the amplitude, it will also change the limitation. Let's say right now I have a smaller amplitude, and you might have a bit lower frequency that you can reach. So let's say we set the amplitude as 1, and let's say it requires us to give a more higher frequency. Let's say we'll use 100. And then, okay, as we have two different input, then we'll give another sinusoid or function generator. Simply, we can just copy this module and copy and paste. So we have one more, and we connect each one of them. And here for the copied one, we'll use a different frequency so that we can see some interesting results. And after that, as I mentioned last time, you can double click this N1 and N2, And to change it to a different name that you will be more familiar with, I'll change it to input 2. And another one, I will change it to input 1. So, like I mentioned, okay, we'll insert a new cam that is called sample and also hold. I'm going to tell you what it is soon. So let's say go to sample and hold. And I'll choose phase 1. You see you can choose phase 1, either phase 1 or phase 2. Let's choose phase 1. The reason you might ask why you choose phase 1, as I mentioned that different modules, they are working with different phases. You see this small value is that output of this module is working only with phase 1. And input of this module is only working with phase 1. So we have to make sure the phases matches. And if you change it to phase 2, let's say I change it to phase 2, it will give you the warning. You see, right now it become a dashed line instead of a solid line. And from the warning, it tell you, okay, there is a phase mismatch. Then we need to, for sure, since they are working with different phases. And I will show the results to you, and you will see why different phases are working differently. So basically, in a single clock frequency, FPA have two different phases, either phase 1 and phase 2. So when the module is working only on phase 1, that means on phase 2, it's just 0. You have no any real values. Well, I shouldn't say real value. The value is just 0 all the time in phase 2. Okay, so like what I teach you last time, you can use the oscilloscope probe to check the results. You can do it from two different ways. The one way is right click of your mouse and just say, okay, create oscilloscope probe, and you have one. Let's say you put one here. Another way you can do it from here, you say from here there is a little tiny probe symbol just next to same. So if you click it, it gives you another oscilloscope probe. There is also a third way. Let's say you can go to simulate, and from simulate you have create oscilloscope probe. So a lot of different ways. Just suit yourself to try either one of them and see whichever one works best for you. Okay, right now our circuit design is ready, and we need to set up our simulation. Go to simulate and set up simulation. You can make it a bit longer time. So instead of 100 microsecond, we can make it maybe 10 millisecond. And click OK, and let's say we simulate it. Right now, you can see that from the bottom left, it tells you what was the current process or progress. In total, we have 80K iterations. Right now, I only finished maybe more than half, maybe 60 to 70%. And whenever this is done, then your simulation will also be finished. Right now, don't look at both of them at the same time. So let's look at either one of them at one time. So we'll look at the sample and hold one. Let's say we turn off the channel 1. This is the pink color. We turn it off. Okay, from the channel 2, this is the result after the cam was going through the sample and hold module. And as you can see, it looks very smooth and also continuous, right? And let's say I turn it off. We look at the channel 1. Right now, it's kind of hard to say what was happening. Let's zoom it a bit. Okay, if you zoom it a bit, you say, and use the cursor. You say, read the result from here. The voltage right now is 1 volt, minus 1 volt, and you see from another one, it becomes 0, right? So it basically is only working at one phase at a time. So if you go to the next one, okay. It doesn't show anything. So the reason is because it's basically only working at a phase at one time. If you look at the sample and hold one is working continuously in both phases. Let's turn the sample and hold one on and compare them at the same time. So if you look at the sample and hold one, you see it is very continuous, right? but since they are doing the sample and hold, it will give you some delay. Let's zoom it even more. You see there is a clear delay. You see the sample hold result 1.64 volts, right? And another maybe half a cycle before there is another 1.64 volts. So that's very, I would say, reasonable. As you are using the sample and hold, it should introduce some sort of delay. And but this sample and hold can let you actually have a continuous results. It will work both at phase one and phase two. You see this one at phase two, it's just not. Let me just show you. At phase two, okay, it might be difficult to see from here, but at phase two, you can see that it's basically at zero, right? If you read it, it's basically at zero. So other than that, so one more interesting stuff that we can say, let's say, uh, as we know, right now, you know like what I mean for phase mismatch, right? And if you just open up the documentation of one of the CAM, let's check out its documentation. And you will say, okay, it said that this cam will produce half cycle output on phase one, right? Since it mentions it can only work with phase one. Another is that, okay, the cam only produce the half cycle output on phase two. So that means either one of them can only work with one phase at a time. And if you scroll down, you will see the more detailed uh, design of the circuit. From what I understand, since FPAA is working on switch capacitor technology, and each one of the capacitor, if you switch it on and off at different phases, it actually gives you a different effective results. And I'm not a very as a good expert for switch capacitor technology. I only understand its basics. But if you would like to know more details, you can dig through from the documentation more and even share your own ideas with me. So other than that, okay, as we know, like right now, if you have a mismatch of the phase, it wouldn't work, right? Like I just showed, if you change it to phase two, it will give you an error or a warning. If you run the simulation, it wouldn't give you the correct results. So it just become the dashed line. So you can see whenever it becomes dashed line, that means this general warning or phase mismatch. While when you look at those two sinusoid function generators, you didn't see any phase assigned as your output, right? Whenever this happens, that means those modules work both with phase one and phase two. It doesn't really matter which, whatever phase. It's basically similar as this one. After you use the sample and hold, it also didn't give you a output phase, right? That means it can work both with phase one and phase two. So one more thing, like I would like to mention is, let's say we would like to change or lower. Let's say we would like to lower the oscillator frequency. Right now, when amplitude is at one, the smallest frequency is 96 kilohertz. We would like to, let's say, change it to a much lower value. What you can do, what we can do is that put your cursor just inside of the FPA, any places or any locations, and double click, you will see the clock frequency settings. So right now, everything is selected as system one, and you can also change it to system two as you want. But right now, we will just only work with system one. And when you change system one, the clock frequency, you change it from here. You say at the very top, you have system one, system two, and what was the current clock frequency. The maximum clock frequency right now is 16K. Let's say we lower it to a much smaller value. We make it half of the maximum. So right now it becomes 2 kilohertz. And whenever that happens, we'll just click OK and go back to our module. We still use clock 0. Since clock 0 from their Anadigm FPAA company, one of the very senior or experienced technician, he mentioned to me that clock 0 is their mean clock frequency. They would like suggests us to work with clock 0 most of the time. So I will just follow the rule and I will work with the clock 0. Right now it becomes 500 kilohertz. Look at here. Same amplitude. Right now you can lower it even to 12 kilohertz, right? Let's say we lower it to 30 kilohertz. No any troubles, right? And just click OK. And another one, let's say we can lower it to maybe 30 kilohertz. And then you can run the simulation again to check what will happen. Since right now they are running at a much slower frequency, we can increase the end time to maybe 20 milliseconds. And there are two ways you can run the simulation. One way, go to simulate, as what I did right now, and from here just say, okay, begin simulation. Another one, quick way, there is a very small, tiny symbol. It said same. Just click it, it starts simulation. And here you can also check out how what was the current progress, and it's just finished. Let's say what will happen. We can, okay, so right now still from here you can see, right, the sample and hold one always have a one clock almost half of the clock delay. And you see clock for half of the clock it have the value, another half it doesn't, right? But for the sample and hold it has the value all the time, right? You see the green one, it have all the values for the entire clock frequency. But for the for the phase 1 output from the cam, since it's only working with phase 1, you say for half of the cycle it has the value, another half, no, it doesn't, right? It will just become 0. If you read it from here, it's 0 volt. So let's just turn off the half cycle one. We will only check the continuous result. Okay, this is what was happening if you add them together. I also make sure FPAA is only working with the voltage that is ranging from -3 to +3 volts. Check all of your module, their input and output. Make sure they are not higher than 3 volts or lower than -3 volts. So one last thing I might need to mention is, okay, how you can check the capacity of your FPAA, right? So you see here, there is a half circle shape like a button. Just click it and you would say this is your current capacity or power consumption of your FPAA. You can also read it, there is a power consumption here. My one, I mean the way how the sightings are showed is a bit messy, but if you change your display sighting, you will see it more clearly. So right now, let's say I will add one more sinusoid or one more function generator. So here I choose sine wave oscillator and add it here. After I add it, let's say I add it right now, you will check, you will see what will happen. After you add it, you see cap 4. Right now, it's almost filled up. So that means whenever you have one more cap that is added to a single FPAA, then it is consuming more of its components. Then if you would, let's say, I would like to have one more, let's say, function generator. Let's say I try to add one more sine wave oscillator, and you move around, it just tell you, okay, we couldn't. It's just if you try to add one more function generator or sinusoid, that's already beyond the capacity. So what you can do right now, either you add one more FPAA. Let me just show you quickly here. You said, okay, insert new chip. So what we are using right now is AN231E04. And if you add one, okay, right now, here it is. Okay, after you add it, then you can basically put this function generator over there. Oh, sorry, that's the old one. since you are trying to add one more, so then that's not possible. You cannot add it at the original or previous FPAA as it is already higher than its capacity. You can add it here. You see, it doesn't give you the warning, so you can add it here. If you add it here, you there is more details to explain. So I will just explain it in the next tutorial. Feel free to leave comments from my channel. If you really like it, you can also subscribe to my channel. At last, I would like to mention so here, this QR code is me and also my supervisor, our research lab. And feel free to check out what we are working on. If you also feel interested, you can also check more details from our lab website from here. So my supervisor, I would say my previous PhD supervisor, he already started his own startup, and we will have our own company startup website soon in the next 1 to 2 weeks. And I really appreciate your time. Let me know if you have any other questions.